Hello guys, and welcome back to another episode of chemistry. And of course, today we're going to continue with our study on alkenes. Just that for this class, we're going to be looking at the reactions that alkenes undergo. Okay, so I'm going to be looking about the reactions of alkenes. All right, do not forget that this video tutorial is brought to you by the one and only O3 Schools JAMB CBT practice app. In order for you to succeed in your exam, the app has decided to also teach you. All right, so please make sure you go to the Play Store immediately and download the application and start practicing your way to success. We're going to talk about the app much later on, but let us see a question from the application. This is a JAMB pass question, chemistry 2020 chemistry question number 19. All right, it is being displayed on the screen right now relating to this topic. It says ethene, which is an alkene, reacts with hydrogen bromide to give A, CH2Br2, B, CH3, CH2Br, C, C2H2Br2, D, CHBr2. Okay, this is called mechanical addition. All right, so we're going to answer this question at the end of the class. We're going to answer this question and many other ones, okay, that we have searched from the O3 School JAMB app. Okay, so this app has all the features designed to make you succeed in your exam, has all the past questions for your exam, has question search feature. It even has class notes, okay, that you can study and then build your build. In fact, after having that class note, you don't even need to go and get any textbook anywhere. All right, what is more is that the question search feature you can use, like go to the app, search for alkenes. All the questions that JAMB has set under alkenes will come out for you to answer. Also, we also have the UTME mock challenge, a challenge that will conduct for all students that are writing JAMB for this year. You compete with your mates, win a lot of prizes, see your score released every Saturday. So thereby building your confidence towards the main exam. So please do not sleep on this application. Go to Play Store, download it. Activation fee is just a little token. Make sure you pay the sacrifice and activate. We're going to come back to this question and many more later on. But for now, let us see the reactions that alkenes undergo. Alkenes undergo various addition reactions, because we have said that alkenes are favored by addition reactions mostly. But mind you, they also undergo substitution reactions, and they also undergo what we call cleavage reaction. All right, so but they will undergo a lot of addition reactions, which in most of them convert them to alkanes, or in other cases it converts them to alkanes, depending on what is being added, depending on the compound that is being added. So we're going to be looking at the addition reactions of alkenes first, before we now go to the substitution reaction. Then we'll now go to the cleavage reaction, which is a very, very, very important reaction that we need to look at, which is ozonolysis. All right, let's just go to the board. And so if you have not like this video, what you are doing is very wrong. Liking this video will make other students easily find this video. All right, so please do not forget to give that video a like right now before you continue. Likewise, do not forget to subscribe to this channel. Subscription is free. So what do you get? What do you get to lose? You get notification whenever we release any new video. So it's also to your advantage and to help the channel grow. Do not forget to share this video also to your friends and loved ones. All right, so let us go to reactions of alkenes. All right, and the first ones, like I said, I'm going to looking at is addition reactions. The addition reactions of alkenes. Reactions of alkenes. All right. So the first addition reaction we are going to look at is the addition of hydrogen, the one we call catalytic hydrogenation. All right, catalytic hydrogenation. So the first one we are going to look at is addition of hydrogen. This one is the one we call catalytic hydrogenation. Okay, I think we'll look at this question in the last episode where we talk about preparation of alkenes. Okay, where alkenes react with hydrogen, okay, in the presence of a catalyst. It's called catalytic hydrogenation. All right, so what happens is that alkenes react with hydrogen in the presence of catalysts like platinum, palladium, and nickel to now form an alkane. All right. So alkenes react to what with hydrogen in the presence of catalyst to now give what an alkane. Let us see that reaction. So this is what happens in catalytic what hydrogenation. We are going to see what an alkene like this. All right. This is what ethene, for example, now reacting with what? With hydrogen in the presence of what? Of catalyst. The catalysts are what? Platinum, okay, palladium, and nickel. Okay, so when they do this, when these catalysts are act on this reaction, it leads to the formation of what? Of an alkane. All right, of an alkane. There's no need to complete this because this is just the general what formula for what? For the reaction. So this is the general formula for the reaction where an alkene reacts with hydrogen in the presence of this catalyst to give what? An alkene. It's as simple as ABC. So let's say, for example, we have what? Ethene. Okay, if it's what ethene that reacts, so I'm going to have C, the bonded to C. We can complete this structure now because this is a general formula. That's why we did not complete the structure. But because we want to use this in a reaction, we have to what? Complete what the structure. So this is your H. This is your H. Then this is a 1, 2, 3, 4. We complete here also 1, 2, 3, 4. This is your H. This is your H. Then, of course, plus what now? H2. All right. Then, in the presence of what? Of this catalyst, platinum, palladium, and nickel. Take note of what? Of the catalyst. Then, to now give us what? An alkane, CC. All right. We can complete our structure. H, 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 H. All right. So this is what happens. Okay. So this is what ethene now reacting with what? With what? With hydrogen to now give us what? What? Ethane. All right. Because an alkane is formed. An alkane is the product of what? Of that reaction. This is ethene reacting with what? With hydrogen to give what? To give what? Ethane. So this is just what simple what reaction. I'm sure that one is very, very clear, right? So this is the first addition reaction that we're looking at, catalytic what? Hydrogenation, where an alkene reacts with hydrogen, okay, in the presence of this catalyst to give an alkene. So let us now continue. Let us look at another what? Addition reaction that alkenes undergo. And this one is called what? Halogenation. It's called what? Addition of halogens. All right? Addition of what? Of halogens. Number 2, that is B now. Addition, B, changing this to B now. Addition of what? Halogens. Okay, the one will now call what? Halogenation. Okay, so alkenes react with halogens, all right, to give us what we call what? A dihalide. All right, to give us what we call a dihalide. It's as simple as that. Okay, alkenes react with what? With halogens that to call what? Halogenation to what? To form what? A dihalide. Let us see what a reaction or a general formula for the reaction. Okay, because this time now it's not hydrogen but what? An halogen. All right, so let us say we have an alkene like what? Ethene. All right, reacting with what? With an halogen. Okay, let us say halogen will be what? Will be X, will be diatomic, X2. Let's say the halogen is what? Is X now. It will be what? X2 because halogens are what? Are diatomic. Chlorine, bromine, iodine, they are all what? Diatomic. All right, so this is ethene reacting with what? With an halogen X2 to now give us what now? It leads to the formation of what? A what? A dihalide. We're now going to have C. All right, the bonded to C. Okay, not double bond now because the double bond will be broken. All right, I'm now going to have what? X. I'm going to have what? X. This is the general formula for the reaction, whereby an alkene reacts with what? With an halogen to now give us what? A dihalide. To give us a dihalide. All right. So now let us see what an example. Let us say ethene now is the what? Is the alkene. Okay. Let's say we are considering what ethene. If ethene is the alkene, okay, and then let's say the halogen now. The halogen, let's say it's what? Is chlorine. Okay. All right. So in this case now, simple as ABC. We can now find what? Our reaction pathway. The ethene will now be what? C, double to C. Of course, we'll complete our structure now because we now have to what? We already know we're using ethene. Then plus halogen, chlorine, Cl2. So it's now going to give us what now? C. Single bonded to what? To C, then here Cl, then here Cl. All right, then we can complete our structure. 1, 2, 3, 4, 1, 2, 3, 4. This is H, this is H, This is H, this is H. All right. So we can find the name of this compound. What is the name of this compound? Of course, this will be what now? If a number like this 1, 2, or number like this 1, 2, it does not matter. Okay, because the chlorine is the same group that is what is in the that is in both what carbon that is attached to both carbon atoms. So this will be what now? 1, 2 dichloro what now? Ethane. All right, so this is what? A dihalide. All right, so an alkene will react with an halogen, okay, in the process called what? Halogenation, to now give us what? A dihalide. All right, this is what the reaction, the general formula for the reaction, an alkene with an halogen, a dihalide. All right, so if the alkene is what? Is ethene, and the halogen, for example, is what? Is chlorine, they are going to have what? This reaction pathway, ethene plus chlorine, to give us what now? This 1,2-dichloroethane. I'm sure that one is also very, very clear. But so let us now see another addition reaction that is what? Undergone by what? By alkenes. And this one is very, very important. This one we'll call it what? Addition of hydrogen halide. All right, to give haloalkane. Okay, to give haloalkane or alkyl halide. So we're now going to have what? Addition of what? Of hydrogen halide. Okay, so let us take this off. Another addition reaction. Addition of what now? Hydrogen halide. Okay, this is what now? This is not the third reaction we are looking at. The third addition reaction we are looking at. So an alkene will react with what? With hydrogen what? Halide. What does hydrogen halide mean? That means what? An halogen. Okay, that has what? Hydrogen, or an hydrogen that has what? An halogen attached to it. That is what? Hydrogen what? Halide. Okay, so do not let the word confuse you. It's very, very easy to understand. Okay, so let us say, for example, the general reaction pathway. Let us say we have what? C double to what? To C, then of course plus what? Plus hydrogen halide. That is hydrogen and an halogen. X is the halogen, then this is what? Hydrogen. Okay, and alkene reacting with what? With hydrogen halide. This will now give us what now? The double bond will be broken, of course. All right, and I'm going to have C single bonded to what? To C. They are now going to have what? This what? What do you call this? What? Halogen attached to what? To the product. Okay, so now this is what happens in addition of hydrogen halide, whereby alkenes react with hydrogen halide to what? To give us what? An alkyl halide, or what? An haloalkane. It gives what? An alkyl halide, or what? An haloalkane. Let's say, for example, if the alkene is what? Is propene, for example. Okay, and let us say, for example, that the halogen is bromine, and the halogen is what? Is bromine. All right, so that means we can now write our reaction pathway. So now this will mean that what? Propene has how many carbon atoms? 3 carbon atoms. So C, prop 1 in propene. Okay, C single to C, double to what? To C. This is propene or prop 1 in. All right, reacting with what now? Hydrogen halide. Because it's bromine, and that is what now? HBr. Abi? Then of course I'm now going to have what? This. So what will happen is that what? This double bond will be broken. All right. So I'm going to have what? C, single bonded to C, single bonded to what? To C. And I'm going to have what now? Br here. All right. So it's as simple as A, B, C. What is this compound called? Let us complete this compound. This is 1, 2, 3, 4. 1, 2, 3, 4. H, H, H. Okay, then this was 1, 2, 3. We just need one H here. Then this was 1, 2, 3, 4. It will be what? H here, H here. Okay, or we can, because of space, that's why I didn't put it here. You can put it here. Okay, it does not mean anything. All right, so now let's all complete this one. Of course, this will complete. This will be complete. This will be complete. H, 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 H. Okay, yes, also what? H. All right, so now if you want to name this compound, this will be what now? 1 bromo what? Propane. Abi, that will be what now? 1 bromo propane. All right, so this is what an haloalkane, okay, or alkyl halide. So this reaction is very, very important. It's very, very, very important. This reaction is called what? Markovnikov what? Addition. It's called Markovnikov's addition. Very important. Take note of it. Do not sleep on this what? Reaction, okay? On this addition reaction. It is called what? Markovnikov's what? Addition. Markovnikov's what? Addition is a reaction between what? an alkene with what? With an hydrogen what? Halide, all right, to give us what? An haloalkane or alkyl halide in the absence of a peroxide, okay? In the absence of a peroxide. Let me go over it again. I said that mechanical what? Addition or Markovnikov's reaction is a reaction between what? An alkene with an hydrogen halide to now give us what? An alkyl what? Halide or what? An haloalkane in the absence of what? Of a peroxide. The peroxide we're talking about here could be any type of what? Peroxide like what? H2O2, BaO2, also Na2O2. Okay, so in the absence of what? Of all these peroxides, okay, so this is what mechanical what? Addition, a reaction between an alkene with an hydrogen halide to give us what? An alkyl halide or what? An haloalkane in the absence of this peroxide. But if these peroxides, okay, are present during the reaction, okay, if they are acting as catalysts during the reaction, we do not call this reaction what? A Markovnikov's addition. Again, we call it an anti-Markovnikov's addition. Anti-Markovnikov's addition. All right, so please, you must take note of what? Of that. So in the absence of what? These peroxides, okay, we call it what? Markovnikov's addition. But in the presence of these peroxides, we call it an anti-Markovnikov's addition. All right, so I'm sure that is very, very clear to you. Please, the reaction is very important. If it were not so, I would have told you. All right, so let us go to the next addition reaction of what? Of alkenes, okay? And of course, I'm going to see what? Addition of water. All right, of course, if water is added to what? To an alkene, all right, what does it form? It obviously will give you what? An alcohol, all right? It results in the formation of an alcohol. All right, so now we're not going to have what? Addition of what now? Of water, okay? Addition of water, all right? Addition of water. The one we now call what? Hydration, okay? We'll call this what? Hydration. All right, so it results in formation of what? Of an alcohol. All right, let us see what the general pathway, general formula for what? For this reaction. Okay, so let us continue. So I'm going to have what? Our carbon, the bonded to what? To carbon, that's what? Ethene, the simplest what? Alkane. All right, then what? Plus what now? Plus H2O. All right, so now an alkene reacts with water. All right, in the presence of what? Of hydrogen what? Ion. All right, then this now leads to the formation of what? Of an alcohol or what? An alkanol as we have it. So the alcohol also, we have what? How many carbon atoms? 2 carbon atoms. You must take note of that. All right, the alcohol, we also have what? 2 carbon atoms. All right, so now if we're having our product now, this will be what now? C, single bonded to what? To C, because the double bond will be broken. All right, we're now going to have what now? OH here. All right, then I think that is that. All right, so this is what? Addition of what? Of water. This is hydration, reaction of what? Of an alkene plus what? With water in the presence of what? Of hydrogen ion to give us what? An alcohol. To give us what? An alcohol. So for example, if what the alkene is, let's say is propene, for example, let us use propene, all right? Or let us use butane, all right? If the alkene, let's say is what? Is butane, all right? We can now what? Do what? Our reaction. Okay, so that means this will be what now? C, the body to what? To C. This is butane because it has what? How many carbon atoms? 4 carbon atoms. All right, we can complete our structure. We can complete them. This is what now? 1, 2, 3, 4 complete. 1, 2, 3, 4 complete. 1, 2, 3. Then we need what? Another 4 here. Another 1 here to make it 4. H. Then now this is what? 1, 2. Then of course we need what? 1 here again to make it what? H. All right, so simple. Let us check again whether we are correct. Sorry, this we need 1 more. This is what? 1, 2, 3, 4. This one carbon atom is satisfied. 1, 2, 3, 4 is satisfied. 1, 2, 3, 4 is satisfied. 1, 2, 3. We need 1 more here. Okay, to make it what? Complete. All right, so this is what? Our butane. Okay, reacting with what now? With water, which is what? H2O in the presence of what? Hydrogen ion. So you see, it's very, very easy. You see the way we are going gingerly. no wahala. So let us go. What I'm going to have now, the alcohol that will be formed, or the alkanol that will be formed. We also have how many carbon atoms? 4 carbon atoms. You must know that first. Okay, so this will be what now? C. Okay, single bonded to C, single bonded to C, single bonded to C. That's what our alcohol. And of course, now the position of double bond is where the OH will be. It's on the first carbon. So our OH will be here. All right. So now we can complete our structure. H. Okay. H. Okay. 1, 2, 3, 4. Complete. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so what's the name of this compound? All right, this is of course butane. This is butane. Okay, it has 4 carbon atoms. All right, and the hydroxyl group. When we are naming alkanols, we are going to talk about naming alkanols also, or alcohols. Okay, we are naming alcohols. We give priority to the what? To the hydroxyl group. Okay, so it's the functional group. If I'm naming what? Alkenes. Alkenes do not have any functional group. That's why we give priority to the substituents. When we're naming alkenes have a functional group. They have a carbon-to-carbon double bond. That's why we give priority to the carbon-to-carbon double bond. When we're naming alkynes have a functional group, which is the carbon-to-carbon triple bond. That is why we give cognizance. We give cognizance to to the carbon-to-carbon triple bond. When we're naming alkanols have a functional group OH. So we give credence to to the OH group. All right, so if we want to number, I'm going to number from here to here. This is what OH, okay? So that will be what now? Butan what now? 1 what? All. All right? It's as simple as ABC. Butan 1 all. Because the all is what? Showing that it's an hydroxyl group. Okay? It's as simple as that. All right, so this is what? Butene. This is butene here. Reacting with water in the presence of hydrogen to give us what? Butanol, okay? Or butan 1 all. It's as simple as ABC. So this is the fourth what? Is this the fourth one? Yes, this was the fourth addition reaction we look at, okay? Which is what? Hydration, the addition of water. The addition of water in the presence of what? Of hydrogen ion to now give us what? An alcohol. So let us now see the fifth what? Addition reaction. Okay, and this one is called what? Halohydrin formation. Halohydrin formation. Okay, this one means what? We are adding an alkene to an halogen and water to now form what? An haloalkanol. Okay, or what? An hydrogen what? Halide. Okay, addition. Okay, this one's called what? Halohydrin formation. D. This will be E, the fifth addition reaction. E. So halohydrin formation. Okay, so this is another what? Addition reaction that alkenes undergo. Okay, so halohydrin formation is a reaction between what? An alkene. Okay, and what? And halogen plus what? Plus water. Okay, which leads to the formation of what? Of an alkanol. Okay, it leads to the formation of an haloalkanol and hydrogen halide. To lead to the formation of an haloalkanol and what? Hydrogen what? Halide. Okay, haloalkanol means that what? It will be an alcohol, but it will have what? An halogen. Okay, in the what? In the structure. You get it, right? So halohydrin formation is a reaction between what? An alkene and what? An halogen and what? And water. So then we are going to have what? 3 what? Reactants. Okay, so we say it's the reaction, the general formula for the reaction now. Okay, let me just write reaction between an alkene, okay, an alkene, an halogen, and water to form what? An haloalkanol, to form an haloalkanol and hydrogen halide. Please take note of that. Okay, reaction between what? An alkene, okay, an alkene and halogen and water to form what? An haloalkanol and what? Hydrogen halide. That is called what? Halohydrin formation. Another reaction of what? Of alkenes. Let us see the general formula for reaction. That means we have what? An alkene like this, C, double bonded to what? To C. Then what? Plus what now? An halogen. Okay, let's say halogen X2. Then plus what again now? Water. All right. So this is what the reactants. We say that what? They are going to be what? 3 reactants. An alkene, an halogen, and what? Water. Resulting in the formation of what? Of an haloalkanol and hydrogen halide. So we're going to have what? An haloalkanol, C, single bonded to what? To C. We're going to have what now? An alkanol here, OH. Then here what? Cl. Okay, sorry, X, because we have not said the halogen should be what? Should be what? Chlorine. Okay, so here will now be what now? X. Then plus what now? Plus hydrogen what? Halide. All right, so I'm going to have H what? X. This will be what? The total pathway for the what? For the reaction. An alkene plus an halogen plus water forms what? An haloalkanol and hydrogen halide. Okay, so this is the alkene. Alkene. Okay, this is the halogen. This is water. Okay, then this is what? The haloalkanol. And this is what? Hydrogen halide. All right, so if I've known that now, that means we can now go over and what? And now what? And now look at what the reaction proper. Let's say the alkene we're looking at, for example, is what? Let's say we use hex3-ene. Let us use hex3-ene, for example. So if the alkene is what? Hex3-ene. All right, and let's say the halogen is chlorine. Halogen is what? Is chlorine. All right, so we cannot have what? Our reaction. All right, so let us come over here and what? And draw what? A proper what? Chain of reaction for what? For this. Okay, hex3-ene, that is what? Having how many what? Carbon atom? 6 carbon atom, because of what is hex3-ene. So I'm going to have C. C. I'm drawing my 6 carbon atom first. 1, 2, 3, 4, 5, 6. All right. I'm drawing them first, and then I talk about hex3-ene. That means the double bond is on the 3rd carbon. I'm starting from here. This is 1, 2, 3. Okay. I mean the double bond is what? Is here. All right. Then hex3-ene plus what? Halogen is chlorine. That's what? Cl2. All right. Then of course plus what now? Plus H2O. All right. So what will now be the product? That is what we are saying. Okay, I'm going to take this off. Let me take this off so that I'll write what the product of the reaction here. All right. So you know that the haloalkanol that will be formed. The haloalkanol that will be formed. We also have how many what? This will be extra there, and this is what? OH. We have what? 6 carbon atoms also. So I'm going to have what? C. 1, 2, 3, 4, 5, 6. Okay, not 7. All right. Remember, the double bond will be what? Will be broken because it's an additional reaction. Okay. So now it's broken. Then now I'm going to have what? And our haloalkanol. Now, what you need to consider here is the position of what? Of the double bond, so that you know where you draw, where you put your OH group. The OH group here, you can see you put it on the 1st carbon. All right. Because what? The double bond was on the 1st carbon. So the double bond here is on the 3rd carbon. So that means that what? Our OH group will also be what? On this 3rd carbon. Then that means we are going to have what now? Here we are going to have our OH. Then here we are going to have what? Our Cl. All right. Then plus what now? HCl. All right. See, this will be what? The product of what? Of our reaction. Okay. A reaction between an alkene plus what? An halogen and what? Water to give us what? An haloalkanol. All right. Then plus what now? Plus hydrogen chloride. You can name this compound. Let us name this compound. Let's name this compound. Okay, let's name this compound. Okay, so remember this is H. All right, H. We are completing the structure, so we can name it HH. All right, so now this is what an haloalkanol. What will this one be called? The position of the hydroxyl group is giving what? Credence. Okay, so that means what? If I'm numbering from what? From I'm going to number from what? From left to from right to left. So this is 1, 2, 3. Okay, the substituent chlorine is on the what? On the 4th carbon. So I'm going to have what now? 4 chloro. Okay, 4 chloro what now? Hexanol. Okay, 4 chloro. 4 chloro hexan. How many all? The hydroxyl group is on the 3rd carbon. Hexan 3 what? all. Okay, it's very, very easy. All right, when we get to what naming alkanols or alcohols, it will become very, very clearer for us to understand. All right, so that's what the I think that the fifth addition reaction I'll look at, Halohydrin formation. So now we're going to take this off, and then let us now look at the sixth addition reaction we are going to look at. Okay, and this sixth addition reaction is called hydroxylation. Okay, we call it hydroxylation or glycol formation. Hydroxylation or glycol formation. Let's see. Hydroxylation. Okay, we call it what? Glycol formation. Okay, it's a reaction between what? An alkene and a permanganate. You know what permanganate is, right? KMNO4. Okay, this is what permanganate. Okay, it's a reaction between an alkene and what? And permanganate under the influence of what we call performic acid. Under the influence of performic what? Acid is HCO2OH. This is called performic acid. A reaction between an alkene and permanganate, KMNO4, under the influence of what? Performic what? Acid. And what this results to is the formation of what? Of a diol. It leads to the formation of what? Of a diol. Okay, a diol is an alcohol that's having two hydroxyl group. Get it? All right. So let us now get the general formula for the reaction, so that we can now take an example to explain further as we have been doing. Let us say, for example, we are using what? Okay, no, let us talk about the general formula first. And a reaction between an alkene, this is what? 18, then plus what now? KMN, this is O4. Okay, in the what? In the presence or under the influence of performic acid, HCO2OH. Okay, leads to the formation of what? Of a diol. And I'm going to have what now? COH. Simple as ABC. All right. So reaction between an alkene and permanganate, okay, under the influence of performic acid to give us what now? A diol. It's as simple as ABC. All right, now let's say, for example, the alkene, let's say for example, the alkene we're using is what? Propene. Let us use propene, for example. Propene will be what now? C, the body to what? To C. This is what? Propene. Okay, or prop1. Some people call it prop1-ene. But you can use prop1-ene, you can use propene, okay? But there's no actually prop2-ene, because if we put double bond here, okay, that means we are going to start counting from here. You get it now? So there's no prop1-ene, so we can just call it what? Propene. So let us complete this structure now. This is 1, 2, 3, okay? Here before H. Okay, then this is 1, 2, this is 3, this is 4. All right, this is what now? Propene. That's our propene. Okay, reacting with what now? KMNO4, okay, under the presence or influence of performic acid, HCO2OH, to now give us what now? A what? A diol. Okay, so the alkanol, okay, that will be formed will be what? Having how many carbon atoms? 3 carbon atoms. 1, 2, 3. So I'm going to have what? Our C. That one is what? Sure. Now, the position of what? Of the OH group will now what? Come into play. Where are we going to put our OH group? The OH group will fall what? Will fall where the double bond what is. Okay? That means to be here and what? And here. All right? So now I'm going to have here OH. I'm going to have what? OH. All right? So we can complete our structure. Okay? H. Of course, you can name what? You can name what that compound. All right? That's of course now. That is a diol. All right. So now let us continue. These are the addition reactions that alkenes undergo. These are the reactions that alkenes undergo. The addition reactions that alkenes undergo. Now let us quickly look at what? Substitution reactions that alkenes undergo. All right. So now let us take this off and then look at what the substitution reactions that alkenes undergo. This is addition reaction. Okay. Now look at substitution reactions. Substitution reactions. So we're having what here? Substitution reactions. All right, so let us see the substitution reactions that what alkenes what undergo. All right, and one of the substitution reactions that alkenes undergo is what called halogenation. All right, number one is what halogenation. I think this is the only one we're going to look at. All right, so alkenes what undergo what halogenation. Remember when we talk about what addition reaction? Okay, we said that what once you halogenate, okay, once you halogenate what a double bond, okay, we're going to get what a single bond. Once you halogenate a triple bond, we're going to get what a we're going to get what a double bond, okay, and vice versa. All right, but of course, if it is a substitution reaction, all right, that cannot work. All right, because substitution means that what you are replacing. You are replacing, all right? You are replacing. You are not what? You are not breaking any bond. Bonds are not broken during what substitution, what reaction. So you must take note of that, all right? So in this case now, halogenation, and alkene will react what? With an halogen, all right? And once it reacts with what? With an halogen, all right? It results in the displacement of one of the hydrogen atom from the what? From the alkene, all right? And being replaced with one of the atom of what? Of the halogen. It's as simple as A, B, C. Okay, let us see. So for halogenation, what I'm going to have is what a reaction, okay, where what an alkene will react with an halogen, all right, leading to the what? To displacement of one hydrogen atom from the what? From the alkene, and now being replaced by what now? By an halogen. Okay, so now let us see what we are going to have. All right, so now let us see. I'm going to see how. Let's say you have what our 18 now. All right, reacting plus what now? Plus an halogen, X2. All right, and I'm going to have what now? One of the hydrogen atom what will be replaced. Okay, remember? So I'm going to have what now? C, the bond to what? To C. The bond is not broken. That is what? Very vital. It's very important that you know that what? The bond here does not break. It does not break. All right, so now I'm going to have C, the bond to what? To C. Then I'm going to have what now? One of the what? Atoms, one of the hydrogen atom was being replaced by what now? By an halogen. All right, and then of course we are going to have what? Hydrogen what? Halide. Okay, it's as simple as ABC. So this is what halogenation. This is substitution what reaction of alkenes. They react with halogens, okay, and then one hydrogen atom from the alkene is displaced, okay, and being replaced by what? One atom from the what? From the halogen. All right, this is not addition. The double bond does not break. You must take note of that. So for example, let's say we have what? Propene. Now let us use propene. All right, if we're using propene, and let's say the halogen is what? Chlorine, and then I want propene now. So we're going to have a C, then bother to what? To C. All right, so now then we can complete our structure. This is what? Okay, complete. 1, 2, 3, 4, H. Then plus what now? Let's say we're using chlorine bar, so I'm going to have what? Chlorine. All right, so now remember that what? We use what? Heat. All right, so this reaction is not complete. We use what? Heat. In the presence of heat, low concentration of what? Heat. We must take note of that. So on that what? Low concentration of what? Of heat, resulting to formation of what? Of this. Okay, so now let us continue. I'm going to have what now? This C, the bond to what? To C. Our double bond will not break. Okay, this X now, here we're not going to have what now? Cl. B, then I'm going to have what now? This last one, the hydrogen halide will be what now? H what? Cl. It's as simple as A, B, C. Can complete our reaction. Okay, then this, all right, is complete like this. All right, so this is what? 1, 2, 3, 4. Complete. 1, 2, 3, 4. Complete. 1, 2, 3, 4. Complete. Then plus what? Plus HCl. We can name this compound. All right. This is what now? 1 chloro what? Propene. 1 chloropropene. Okay. Some people say 1 chloro 1 in. Okay. Like I told you, propene does not have prop 2 in. There's no prop 2 in. Prop 2 in. So you can just say what? 1 chloropropene. All right. It's as simple as A, B, C. Now, this is the substitution reaction that alkenes what undergo. All right. So now I want to now look at what the last type of reaction that what alkenes undergo before we round up with this class, and that's one we call cleavage reactions. Cleavage reaction. Okay, the one we call ozonolysis. Cleavage reactions. Okay, we call it what? ozonolysis. Ozonolysis. Okay. In ozonolysis, an alkene reacts with what? With ozone, okay, leading to the formation of an ozonide, okay, and on further reaction with zinc dust and water leads to the formation of an aldehyde and a ketone. All right, so it's very, very easy to understand. Number 3, that is what the third type of reaction, we call them what? Cleavage reactions. Okay, cleavage what reaction? Okay, the one we call ozonolysis. Okay, now we say ozonolysis is what? The reaction. Let me put it down so that it becomes very easy for you to understand. Reaction between an alkene, okay, and what? And ozone, which is what? Ozone is what? O3, all right? Reaction between an alkene and ozone, O3, leading to the formation of what we call what? Ozonide. All right, so this is the first thing that is formed, okay, when an alkene reacts with ozone. But on further reaction, however, okay, let me say, and on further reaction with zinc dust, let me put it in full, zinc dust and what? Water, that is what? H2O, okay, leads, let me put this H2O well, leads to the formation of an aldehyde, okay, and what? And a ketone. All right, so that is what ozonolysis, reaction between an alkene and ozone to form ozonide. On further reaction with zinc dust and water leads to the formation of what now? Of what? Of an aldehyde and ketone. Simple as ABC. So the pathway for the reaction is what? An alkene. You have what? An alkene. Okay, let me just say what you have. What? An alkene. Okay, you have what? Ozone. Okay, then you now have what now? Ozonide. Okay, you now have what now? Again, what? Aldehyde. You now have what? Ketone. Okay, so this is the pathway for the reaction. So let us see how it happens. Okay, so an alkene, for example, let us say, for example, now ethene. All right, ethene, C double to what? To C, will react with what? With ozone, O3. Okay, then this will now lead to the formation of what? Of an ozonide. This is how an ozonide is. Okay, okay, okay. Then I have O. This is what? An ozonide. Okay, but on further reaction with what? With zinc dust and what? H2O leads to the formation of an aldehyde. An aldehyde is CO. Okay, this is 1, 2, 3, 4. Then plus what now? O double to C. Okay, all right. So that is what? This is an aldehyde. This is what? Ketone. All right, so this is what? Ozonolysis. Okay, the reaction between what? An alkene plus ozone to give an ozonide. This is what? An ozonide. Okay, this is what now? Ozone itself, and this is what? An alkene. An alkene, that is what? Ethene. All right, so a reaction between an alkene plus ozone to give an ozonide, then what leads to the on further reaction with zinc dust and water leads to the formation of an aldehyde and ketone. Okay, so you can give an example by yourself, right? I'm already tired and math. Let me explain it. So, for example, if the alkene is what? Is propene, so you can use what? Propene, okay, and then what? Give what? Form the pathway for your reaction. It's as simple as ABC. All right, so now that is what, these are the reactions that alkenes what undergoes. Okay, they may what be other reaction that they undergo, but under the scope of this class, this is very, very okay for you to what to understand. Okay, so now let us go to the O3 School JAMB app, not to waste for that time, and then let us take some questions from the application. Okay, using the question search feature. Okay, this is a 2020 question. 2020 number 19. It is being displayed on your screen right now. 2020 number 19. They say ethene reacts with hydrogen bromide, okay, and that is what, of course, Marconi's what reaction, all right, and the reaction does not give us what Br, does not give us a compound that has what is, does not give us how will I put it? Does not give us a dihalide. All right, it does not give us a dihalide. It gives us what? It gives us an alkyhalide, not a dihalide. All right, so that is why BrO2, anyone that has BrO2 cannot be the answer there. So CH2 BrO2 is wrong. CH3 CH2 BrO is very correct. C CH2 H2 BrO2 is also wrong. D CH BrO2 is also what wrong. Please refer to what our addition reaction on what on Marconi's what addition, so that what you understand what better why the answer must be B, not what any of A, C, or D. Let us see another question. This is a 2023 question, number 4. 2023, number 4. It is being displayed on the screen right now. Also, they say, what type of reaction is involved in the formation of alkanols from alkenes? Okay, what type of reaction is involved in the formation of alkanols from alkenes? Where what an alkene reacts with what now? With water to give us what alkanol. Okay, is it not an addition reaction? So it's an addition reaction. Option B is very correct there. There's no need beating around the bush any longer there. All right. So do you still have any question we want to look at? Okay, this is a 2020 question, number 36. 2020, number 36. It says, the IUPAC names of the compounds CH3, COOH, and CH2 double bonded to CH2 are respectively, of course, CH3, COOH. We have not gotten to carboxylic acids yet, but that is what ethanoic acid. Then CH2 double bonded to CH2 is obviously what and what ethene there. That's why our correct answer there will be option B. All right. So thank you for watching. My name is Master T, your Grand Commander. Okay. So please, dear soldiers, keep striving, keep studying, and keep practicing on this wonderful application. And I wish you all the best and success. In the next class, I'm going to be seeing the uses of of alkenes, and then we'll now move to to alkynes. Thank you for watching.